Hey everyone! Welcome back to A-Level Math Mastery, where complex math becomes clear and success becomes simple. In today's lesson, we are diving into an important foundational concept in real analysis: bounded sets. You'll learn what it means for a set to be bounded, how to recognize if a set is bounded above or below, all explained with simple examples to help you master it with confidence. Let's get started. Let's talk about the meaning of a bounded set in real numbers. A subset, which we call capital S, of the real numbers, is said to be bounded if there exists a real number, which we'll call capital N, that is greater than 0, such that the absolute value of every element in the set is less than or equal to n. In mathematical terms, we write the absolute value of x is less than or equal to m for all x in the set S. This can also be written as negative m is less than or equal to x and x is less than or equal to positive n. This means that all the numbers in the set lie between negative m and positive n. Note, if a set is both bounded above and bounded below, then we say the set is bounded. Let's talk about the concept of a lower bound, also known as being bounded below. A lower bound is a number that is less than or equal to every element in a given set. So here's the formal definition. Let S be a non-empty set and let beta be any number. If for every element x in the set, S beta is less than or equal to x, then beta is called a lower bound of the set S. Now, let's look at an example. Consider the set S equals 1, 1 over 2, 1 over 3, 1 over 4 to 1 over n. This set contains the reciprocals of natural numbers. So when we look at the lower bound, we ask, what is the smallest value that all elements in the set are greater than or equal to? In this case, as n increases, 1 over n gets smaller and smaller, approaching 0. So 0 is a lower bound of this set because all values in the set are positive and greater than 0. But 0 is not in the set, and it is in fact the greatest lower bound, or infimum, though it's not a member of the set. This is an important distinction when working with bounds in real analysis. Let's continue exploring the concept of a lower bound with more examples. Example 2. We are given the set B, which is defined as the set of all real numbers x such that x is greater than or equal to 5. In words, this means B includes every real number starting from 5 and going upwards. So the set might include numbers like 5, 6, 7, 8, and so on, even numbers like 5.5 or 6.1. Since 5 is the smallest number in this set, and every other number in the set is greater than or equal to 5, we say that 5 is a lower bound for the set B. In fact, it is also the least lower bound, because there is no number greater than 5 that is still less than or equal to all the elements in the set. Example 3. Now consider the set D, which contains the elements negative 3, 0, 3, 6, and 9. Looking at this set, the smallest number is clearly negative 3. Since all other numbers in the set are greater than or equal to negative 3, we say that negative 3 is the lower bound for the set D. In this case, the lower bound, negative 3, is also one of the members of the set. In both examples, the idea is the same. A lower bound is any number that is less than or equal to every element in the set. Let's now talk about the concept of an upper bound, which means a set is bounded above. Definition. Let's say we have a non-empty set called S, and we choose any number, let's call it alpha. If for every element x in the set S, x is less than or equal to alpha, then we say that alpha is an upper bound for the set S. In simpler terms, an upper bound is a number that is greater than or equal to every element in the set. Example 1. Let's consider the set A that contains the numbers 1, 2, 3, 4, and 5. So we write this set as A equals the set of 1, 2, 3, 4, 5. Looking at these numbers, the largest element is 5. Since every number in the set is less than or equal to 5, we say that 5 is an upper bound for the set A. Example 2. Now let's take another set, which we'll call E. This set is defined as the set of all real numbers x, such that x is less than or equal to 10. In words, this means the set E includes every real number from -infinity up to 10, including 10 itself, since 10 is the largest value that any number in this set can be. We say that 10 is the upper bound of the set E. An upper bound is any number that is greater than or equal to every element in a set. It helps us understand the maximum limit of the values in that set. Let's continue discussing the concept of upper bound, also known as a set being bounded above. Example 3. Let the set S be the open interval from 1 to 4. That means all values of x in the set are greater than 1 and less than 4. In other words, x is greater than 1 and less than 4. And x is an element of the set S. Now, since all values in the set are less than 4, the number 4 is an upper bound. Also, any number greater than 4, like 5, is also an upper bound, because all elements of the set are still less than 5. So we can see that open intervals can have more than one upper bound. Now, here's an important note. When the set is closed and bounded, the upper bound is unique. For example, if the set S is defined as the closed interval from 1 to 4, then the values of x satisfy the condition that x is greater than or equal to 1 and less than or equal to 4, and x belongs to the set S. In this case, the upper bound is exactly 4, because 4 is included in the set and no number less than 4 can serve as an upper bound. In open intervals, like from 1 to 4 excluding the endpoints, there can be multiple upper bounds. But in closed and bounded intervals, like from 1 to 4 including the endpoints, the upper bound is unique. And that is the largest number in the set, which is 4. So remember, a set is bounded if it stays between some lower and upper limits. And there's even more to learn in our next video. We'll talk about two very important ideas called infimum and supremum. These are like the tightest lower and upper bounds a set can have. So make sure you subscribe and turn on notifications so you don't miss it.